Hey guys, Spencer at Z1. Today we're coming to you from the dyno bay, having a look at one of our newest offerings. That's the high energy ignition coil for the VG30. This is applicable for us mostly on 300ZX applications, so the non-turbo or turbo variant where they're going to have the most benefit to gain. These are designed to benchmark against brand new OEM ignition coils, which they have like a peak improvement of 18% millijoules output compared to a new OE part. Most people aren't running that or getting it for their vehicle. Most of you are going to be actually putting this up against something that's got lots of years and lots of miles on it, so it's a bit more tired. It does happen. Things wear out on these or on the stem, and it affects the performance, how much output you can have for your ignition system. Why does that matter? I covered that once before. We'll rely on that, and then we'll come back to you. Okay, Nissan, in their infinite wisdom, has chosen to make ignition coils in different shapes and sizes, connections, mounting solution. They're different for almost every engine. Some engines even have 2 different part number coils on the same engine. Thanks for that, guys. Very exciting. But even though we may think it'd be nice if they were a little more uniform, we know that there's not a one-size-fits-all coil solution for this market. You got to make sure you have something mounts correctly, stays in place, works like it's supposed to, and doesn't require any other modification, patch harnesses, hardware changes, tuning, anything like that. So Z1 coils, they check all those boxes. They're simple, fit, OE quality, higher output, and they bolt right in. So if you can change spark plugs, you absolutely can change your coils. Nothing else will be needed to reap the benefits. We don't change anything crazy in the coil. The concept here is not new science, as we mentioned before. This has been mainstream popularity, I'd say, since everybody started racing cars. In our system, we don't have like an old school big old can coil and cables that have to run over to control the primary from a distributor with points, and then cables to run the secondary voltage back over to the distributor cap that's then got to transfer to a rotor button and back over other cables and then finally onto a spark plug. No. Lucky for us, modern era, we have coil on plug, they're transistorized ignition. What that means for you is that none of the other stuff has to be replaced, and the chance of a problem with it is far less. Your ECU has been developed extremely heavily to run well in hot, cold, dry, wet, moist conditions, different barrows, all kind of scenarios have been poured into it, and you're not going to have to deal with any changes outside. Just like the OE, we operate the same. We've just beefed up the coil windings. In total, we use about 20% more copper in our ignition coils than the OE. We don't mind putting in the extra investment because we're not buying millions at a time. The good news for that is it will work just the same. So a power source here, when we turn our car on, we send power over to both coils, windings in the coil. We have a primary side and a secondary side. On our primary side, ECU will control the transistor to ground the circuit. When it grounds that circuit, we will get flow of electrons and current, which will generate an electromagnetic field. This whole process is known as the dwell cycle of a coil. It's charge times. We're talking milliseconds, just a few milliseconds, right? ECU says, hey, light it up, and then it will break this ground when it wants to fire at the right time. All the purpose of this is trying to time that spark so that we get firing at the right time and get the most pressure on the downward stroke, on the power stroke, at the right time, so we have the most leverage on our crankshaft. You can actually get them to run at quite the range here of firing time, but there's a sweet spot. Everybody knows that. Sometimes we can fine tune it, especially once we make some upgrades on a truck. But this video is not about that. This video is about how easy it is to just drop them in without having to tune. So when we charge this primary field coil, it makes an electromagnetic field. When the ECU opens that circuit and says fire away, the magnetic field will collapse. When that field collapses, it's all around this conductor. It will induce a voltage. That's how we get from 12-volt systems to thousands of volts. We're not talking 5,000 volts, we're talking like 25, 30,000 volts. These electrons will get moving on this conductor and they'll be looking for a path to ground. They're not going to head upstream to the positive side, so they're going to overcome this zener with their 20, 25,000, 30,000 volts. They're going to head down the spark plug and jump that gap where we see that high voltage reading if we were to plot it. Once it jumps that gap, it will have a spark event which has a little bit of duration. Again, we're looking at things at a milliseconds time here. Not always perfect in there. That's why it matters so much that your ignition system is in good shape. Even if you're at 1,500, 2,000 RPM and you're looking for, you know, good performance, you're cruising, you want to benefit from a good spark light off and from good spark duration so you're not having blowout. We know our biggest problems on ignition are misfire in the total sense and partial misfire, which is much more common. When you have a total misfire, there's no missing it. We've all been there, we got to address it. Partial misfire, shocking how much people put up with this because it usually doesn't progress to be a problem overnight. It happens over time. Maybe you've got 50,000 miles on your truck. It's got some wear on it. Maybe fuel system's not running so perfect. You got a fuel injector that, you know, used to fire a pretty even atomized mist that went into a low pressure in your cylinder on the intake stroke, and that kind of atomized further. You know, in an ideal world, we would just have this homogeneous, perfect mix everywhere in the cylinder, nothing at a particulate scale, you know, that we would think is not perfect. Even when we compress all the way, again, we would hope it would be perfect. And we light it off, symmetry and balance in the chamber would be perfect. And our pressure could be tuned to run in and reach that ideal sense at the perfect time, and we'd burn it completely before we ever got to the cats. Some cylinders, a little more dysfunctional than others, you know? Like I said, some, they maybe got some problems. Their injector's got a few more miles on them, had some trash run through there, had a hard life. So they don't really start off perfect. Pretty common to have a fuel mix that's irregular in the chamber. A lot going on in there. So you may have a firing event that gets a power stroke started and one flame front collides with another. Maybe you have blowout and the spark doesn't happen. Maybe it's a higher concentrated rich mix around the plug and you don't really get a good launch because now your peak KV is really high and you have a short duration. A lot of ways it can go wrong. Best way to get it right is just give it more power all the time. That's always the answer. More power all the time. You know, you want to have this flame front propagate even, perfect, uniform. You want to have that ideal pressure at the right position as the crank's rolling. You want the most output bang for your buck, right? Cruising, whether you're at, you know, idle 1,500 RPM, getting down the road just on the daily grind, or you're like full send at the track and you're running all the way 6,000, 7,000 RPM. Z1 coils are going to help get you there all the time. Without tuning even, same charge duration, same dwell time, Z1 coils are going to have significant more output. Some situations or applications it's 20% more at the max, some it's 60% more at the max. They're going to give you more spark all the time, no matter that charge duration. They're also going to reach what we call saturation sooner. That's the max charge cycle where we've kind of, as much of an electromagnetic field can be established has happened. All right, you're not going to get any more voltage out of it if you sit there and held it internal like longer, just cooking the coil. So this is a great solution that bolts in. It gives us more output. When we think of the energy ratings, 20% more, 60% more, think of that rating of joules like a string. If we take that string and plot it on our waveform, we can have a higher kV supported with still a longer spark duration. The blue graph kind of gives you an idea of what an OEM graph may look like. If things were tougher here and we pulled this event up higher, then this duration would be shortened. Maybe we don't have as much energy, heat, established connection running, and we have two flame fronts collide or something. They kind of partial blow that out. You get a shortened duration and maybe you don't get a complete burn. That partial misfire rears its head again. And you'll still have a longer duration for the full cycle. It's tougher to blow this spark out. On the other hand, should the event need, you know, to have a higher event, somehow we got a lot of fuel around there, or somebody breathed on it with a little bit of boost, we can still handle it at the same gap. And not blow out is easier, not have a shorter duration. So we see good, strong, cleaner burns. Just like what we saw on the dyno graph, we saw that benefit when we wheeled that out and drove it. Instantly the truck felt more alive, more responsive. It just felt fresh and new. You know, we saw the gains were there and we felt them in daily driving and all out, and we wanted to lean on it. For us, the performance gain happened at the low end of the RPM band where static cylinder pressure, if you think about maybe like a compression test, is at its highest. When we see cams in an engine they have volumetric efficiency, and they have sweet spots in their rev range where they breathe. There is a sweet spot in each engine where they generate peak cylinder pressure, and that means more pressure, more compression in the cylinder. Usually that's from like a sweet spot where they have flow for intake and not too much leaking back out past valves as we convert to the compression strip. That sweet spot for us occurred, I think it was about 3,600 RPM. And that's the toughest compression spot for us to overcome here. We saw our biggest gains in performance on this test at that point. When the plugs came out, we looked at them, they looked pretty even as far as the gap goes. None looked really fouled. You look at the coils, they just look like old used ignition coils. Tough to just say, X-ray vision, yes, this one's a little worn on the inside. But we saw the gains nonetheless. We know that our output, improved performance, is what gets us there, gives us that benefit. So we see this actually probably more of a need with upgraded 300ZX turbo models more than any other. You can have some gains in the NA application for sure, but as we have customers kind of hop up or upgrade their Zs, they're running more boosts, they're adding other intake, exhaust, intercooler upgrades, they make that combustion chamber charge denser and tougher for the spark to jump the gap. On those applications, what we'd always do when we turn up the boost is we choke down the ignition ground strap on the spark plug so that the peak kV needed to get across the jump is a little bit less and you can have enough spark duration. When you don't have this, things we see is vehicles that'll break up mid-pull. So you have a car that's running, screaming halfway through the RPM range, it'll get kind of up top and it will break up. You'd kind of hear it kind of toot at you, as it may be from the dyno. You don't want to continue to drive one through that. You can damage it, and then you're dealing with engine problems. You don't want that. So, you know, big benefit here is cleaner combustion, more consistent burn. You reduce the chance of the spark blowout and having misfires or partial misfires. You're going to pick up some power if you're taking advantage of an ignition system that wasn't delivering that. And again, this is ideal for the turbo or the non-turbo application, but you're really going to be able to see opportunity to gain on turbo models, I think, even more so. If you're pushing your own platform, you can start to experiment further with that, trying upgraded ignition and a little bit less of a reduced spark plug gap, and see if you can fine-tune your vehicle to get it run as smooth as you can with the max efficiency on the ignition for the burn. Oh yeah, one more thing. We don't cover this frequently. It's a bit older, well known in the community if you're a 300ZX enthusiast, you've been around good published information for a while, but there is a lot of bad information about spark plugs. If you're not familiar, I think after the first year of production, somehow the parts microfiche got screwed up, and Nissan advised people that the plugs they needed for turbos are non-turbo plugs. These are shorter, non-projected plugs, and the heads did not change. It was a mistake. It went on for years. Everyone sells the wrong plugs. If you go to a parts store to buy plugs, which I wouldn't recommend, if you can't get the right thing, they're going to sell you NA plugs. They're going to tell you it's right. They're going to ask you for that year, make, model. They're going to tell you it's right. They couldn't be wrong. They couldn't be wronger. Cylinder heads on a turbo model have a shrouded spark plug hole opening in the combustion chamber. It literally looks different, and it lays further away from where the spark plug goes in. If you put non-turbo spark plugs into your twin turbo cylinder head, they will not sit down in the spark plug, like in the combustion chamber. They will actually be recessed up in a hole. This causes spark blowout and bad burns all the time. We very frequently are doing dynos on dyno-ready vehicles here that come in to the shop, and they will do spark blowout. They will have poor running condition, and we will pull the plugs and find they have a different non-turbo spec length plug. Don't do it. Make sure you get the right thing. You can get the correct heat range here at Z1. We carry one step colder platinum plugs. We carry some other plugs, but not with the projected tip like this OE piece. So if you want to make sure you're in tip-top form, run as best you can for your bolt-on modified turbo upgraded application, or even on stock turbos with a little more boost, be sure to check that out and take advantage of getting the most out of your Z. All right, guys, VG30 high energy ignition coils. Grab a set today, enjoy the benefit. If you got questions about setting your vehicle up for success, reach out to our team, and keep in mind we've got you covered on everything maintenance, performance, aftermarket, Z1, everything for your Z. We've got you covered, so be sure to check out z1motorsports.com.